Hey guys, welcome to SQO6 programming. Today we will see a program to find whether a given number is prime or not. So here is the code ready. Now int n, so we will take a variable n of data type int. This is a number for which we will test whether it is prime or not. Now cout to find whether a given number is prime or not. Cout, enter a number, cin n. Now here we will take a variable j of data type int and initialize it to 0. So in j is equal to 0. Now here is the for loop. Int I is equal to 2, I is smaller than or equal to n by 2, I plus plus. So we'll start from 2 till the half of that number which we have entered. Now in the for loop, if n modulo I is equal to 0, j plus plus. So we will divide that number with the numbers from 2 to half of that number, and if it's get divided, that is it gives the remainder 0, then we will increment j variable which is initially 0. So let's assume that the number is 11, so we have entered 11. Now I is 2. If 11 modulo 2 is equal to 0, j plus plus. No, 11 modulo 2 is not equal to 0. 11 is not divided by 2, so the if statement is not going to be executed and j will remain 0. Now we'll again go back to for loop. Now this time I is 3. If 11 modulo 3 is equal to 0, no, it's not, it's a false statement, so j will remain 0 and if statement is not going to be executed. Now again we will go back to for loop. Now I is 4. 11 modulo 4 is equal to 0, no, it's a false statement, so we will come out of the if statement and again go back to for loop. Now this time I is 5. 11 modulo 5 is equal to 0, no, it's not, again it's a false statement. Now j is not going to be incremented and we will again go back to for loop. Now this time I is 6. Okay, 6 is smaller than or equal to 5.5, that is a false statement. Now we'll come out of the for loop. So we have completed our for loop. Now we will come here. If j is equal to 0, cout it is prime, that is 11 is not divided by any number, so it's a prime number, so it is prime. So let's assume that number is 10. Now if int I is equal to 2, now 10 modulo 2 is equal to 0, yes, it's 0. Now j is going to be incremented. Now j is 1. Now I is 3. 10 modulo 3 is equal to 0, no, j is not going to be incremented. Now I is 4. 10 modulo 4 is equal to 0, no, now j is not going to be incremented and it remains 1. Now I is 5. 10 modulo 5 is equal to 0, yes, it is true, and j is going to be incremented. Now j is 2. Okay, now I is 6. 6 is smaller than or equal to 5, it's a false statement, we will come out of the for loop. Now if j is equal to 0, cout it is prime, else cout not prime. So j is 2 here and it's not going to be a prime number, it has been divided by two numbers, so it's not a prime number. So let's see what we have done. When n was 11, so we divided 11 from 2 to 5. We didn't bother for number 6 and greater than 6 because 6 into 2 is 12. This is obvious that when we divide 11 by any number greater than 6, it's going to be the remainder is not going to be 0, it's not going to be divided by that number. So we have to test from number 2 to half of that number, so check whether it's going to be divided by that number, that is whether it's prime or not. Now let's test the code. Enter a number 11, it is prime. So here is another code for prime numbers up to 100, which we will see in next video. And let's test for another number 7, yes, it is prime. 10, not prime. So here is the code ready and you can copy this code and try it out yourself. In the next video we will see whether to generate prime numbers up to 100. Thank you and goodbye.